Hello everyone, I'm Jingshuo. I will present my joint work with Chen, Samuel, and Borja. Our topic is human-robot partnership, an overarching consideration for interaction and collaboration. There are many works about human-robot interaction and human-robot collaboration in construction and operations and maintenance fields. For example, in this figure, we can see different types of interface for the interaction between human and robots. But if we go back to the terms HRI and HRC, it's hard for us to find clear definitions of them. And this is what we want to address in this paper. This figure shows the material selection process of us. We used the database scopus and different keyword combinations to cover as much literature as possible. And then we limited our search to the English journal and conference papers published in the last decade, and the subject area was limited to engineering only. After that, we did a manual screening to check the relevance of papers identified and got 117 papers left. Finally, we selected 8 representative papers from the ones identified in the manual screening process. We looked at existing definitions of HRI and HRC. HRI is defined as the information and action exchange between humans and robots to perform a task by means of a user interface. And HRC is the study of collaborative processes in human and robot agents work together to achieve shared goals. We conducted a keyword analysis on pure HRI and pure HRC papers with the open source software as viewer. After removing repeated and useless keywords in the top 20 keywords of HRI and HRC categories, we got what's displayed in this table. We can see that social robot is an important application of HRI. Human is the user, and the human's behavior will be monitored by the robot. But for HRC, a common application is cobot, and both human and robot play the role of worker. Based on the above works, we proposed our definitions of HRI and HRC in the context of construction and O&M. From our perspective, HRI is a process in which humans exchange information with robots through a user interface for control or communication, by which they indirectly participate in the tasks. And HRC is a state in which human workers and robots work together to achieve a certain task. It's worth noting that HRI is just a process of information exchange, but HRC is a state. In an application, as long as humans and robots are working together to deliver something, we can call it HRC. We summarize the key elements of HRI and HRC. In both HRI and HRC, the key element of human is well-being. Humans should be in good physical and psychological state. In HRI, human is the user. There should be a feasible user interface for the information exchange between human and robot, and the robot should be able to recognize the information from human. But HRI can't exist alone because the ultimate goal of information exchange is to enable human and robot to better work together, which is HRC. In HRC, human is the worker, and a good HRC application should be built on reasonable task allocation that considers the constraints of both human and robot. And the robot should be capable of the allocated tasks. But HRC suffers from lack of flexibility because robots only have the pre-programmed skills for anticipated tasks, and there is no room for adjustment. We think that by combining HRI and HRC to form a new relationship, which we call it human-robot partnership, the constraints of HRI and HRC can be overcome. This is because with HRC, the information exchange in HRI can contribute to the task delivery, and with HRI, the HRC applications will be more flexible due to the introduction of user interface for the information exchange. We propose the two future directions. The first one is to use multiple psychological signals. There are already works that use EEG to reflect the cognitive load of human workers, but the effect of other psychological signals like PPG, EOG, and their fusion remain to be explored. The second future direction is the data fusion, especially the fusion of human expertise for HRP-based predictive maintenance. In construction field, human expertise has been explored. For example, in this figure, human can teach a construction robot how to construct the frame through options offered by the user interface. We call this kind of work learning from demonstration. And we think this is a good example of HRP because human can teach a robot how to deliver the task through user interface, which is HRI. And of course, they are working together to deliver the task, which is HRC according to our definition. But in predictive maintenance, which heavily relies on data fusion, human expertise has not been leveraged. We think that fusing human expertise can contribute to both failure prediction and the following maintenance work in HRP-based predictive maintenance. For example, by learning from demonstration, human workers can teach the robot how to conduct maintenance work for the building facilities that are predicted to break down soon. To draw a conclusion for our work, we offer the definitions of HRI and HRC in the context of construction and O&M. We proposed HRP as a combination of them to overcome the constraints of them. And we suggested to use HRP in future works that concern both HRI and HRC. Thank you for your time.